Hey everyone, let's dive right into a really fascinating question. Why do things break? Why do some surfaces, from our phone screens to really critical medical implants, suddenly fail, seemingly out of nowhere? Well, it turns out there's a hidden science that can actually predict these failures way before they ever happen.
I mean, we've all been there, right? You get something brand new, and almost immediately the paint is chipping or some protective layer starts peeling away. It's so frustrating, and it just feels totally random. But here's the thing, it's not random at all.
The truth is, the story of that failure started long before you ever saw a single chip. It all began with these microscopic flaws, tiny, invisible weaknesses hiding just under the surface. And believe me, this isn't just about looks. In high-stakes situations, these tiny flaws can become incredibly costly and even dangerous.
So that's the big problem, isn't it? If these defects are totally invisible, how in the world are we supposed to find them before they grow into a full-blown catastrophe?
And when I say tiny, I mean it. To give you some perspective, the flaws we're trying to hunt down can be as small as 1,000th the width of a human hair. You literally can't see them. A normal microscope won't cut it. To find something that small, we need a special kind of detective.
And that detective? Well, it has a name. It's this brilliant piece of technology that can probe surfaces at the nanoscale, looking for the absolute earliest clues of weakness.
It's called nanoindentation. Okay, the easiest way to think about it is like this. Imagine you're testing how ripe a piece of fruit is by gently pressing on it. Now shrink that down to a microscopic scale. This process uses an incredibly tiny, sharp tip to press into a material surface. And by measuring exactly how that material pushes back, we learn a ton about its strength, its structure, and most importantly, where those hidden flaws are hiding.
So, how does this whole thing work? Well, you can really break it down into 3 simple steps. First, you press that tiny tip right into the coating. Then, and this is the key part, you measure everything, every bit of force being applied and exactly how deep the tip is going. Finally, you analyze all that data, which gives you this curve. You can think of this curve as a secret message from the material itself, a message that's packed with clues about its health.
And that brings us to the real heart of our detective story, learning how to read that secret message. To do it, we have to listen for very, very specific signals, what we could call the whispers of failure.
See, in all that data from the nanoindenter, there are 2 critical events that we're listening for. They're called pop-in and pop-out. And these are the absolute earliest warning signs that a material might be destined to fail down the line.
Okay, let's break these down because this is the cool part. Let's go back to that cake analogy, but this time it has hard, crunchy icing. A pop-in happens as we're pressing down. It's this sudden little give, kind of like the sound of that hard icing cracking under the pressure. That tells you there's a weakness inside the coating itself. Now, pop-out is different. That happens when we start to pull the tip away. This is like the entire piece of icing just lifting right off the cake. It's a dead giveaway that the coating isn't sticking to the surface underneath it. That's your classic sign of bad adhesion.
So, you might be wondering, how important are these signals? Well, it turns out those pop-out events, the ones that signal bad adhesion, are a huge red flag. They're responsible for about half of all potential failures. By catching these whispers early, we can pinpoint the exact reason a surface is weak long before it ever has a chance to become a real problem.
And this isn't just some cool lab experiment, This technology has massive, real-world implications across dozens of industries where having a perfect surface is absolutely critical.
Seriously, the applications are everywhere. We're talking about making sure the coatings on biomedical implants don't fail, which could have serious health consequences. We're talking about guaranteeing the durability of industrial coatings or even the quality of 3D printed metal parts. This tech even impacts our daily lives, from the finish on your car to the screen on your phone.
So the takeaway is pretty clear. Without this kind of testing, companies are really just flying blind, risking their products failing out in the real world. But by building nanoindentation right into their process, they can catch these weaknesses early, fix them, and ultimately build much more reliable and durable products for all of us.
At the end of the day, all this nanoscale detective work isn't just about finding what's wrong. It's about learning how to make things right from the very start.
Because once you can hear these tiny whispers of failure, you gain the power to engineer materials that are just fundamentally better. We can create surfaces that are stronger, way more reliable, and actually designed to last. And that saves money, it improves safety, and it just leads to products we can all depend on.
This basically transforms testing from a simple quality check into a powerful design tool.
The research really says it all. It guides engineers to make better choices from the get-go and solve problems before they even begin. It's a truly proactive way to build excellence right from the microscopic level up.
So as we get better and better at listening to these tiny clues, it leaves us with a really exciting thought. From flexible electronics to the next generation of aerospace materials. What currently invisible failure is this amazing technology going to help us prevent next?